Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss some problem related to capillarity. In our previous video, we have discussed the theory part of capillarity and the capillary rise and capillary fall, and we have derived some equations related to capillary rise and capillary fall. So based on that concept, let's solve some problem related to capillarity. So the question here given, calculate the capillary rise in a glass tube of 2.5 millimeter diameter. So first data given diameter, that is 2.5 millimeter. Okay. And when it is immersed vertically in water and mercury, and consider the surface tension for that, zero point zero 0.0725 Newton per meter. Okay, and similarly the sigma for mercury 0.52. You can see how much difference is there. The sigma value, this is for water and this is for mercury. Okay, in contact with air. Specific gravity for mercury is given 13.6. So specific gravity for mercury is given 13.6, and from here we can identify what is the density of this. That is, we can multiply 1000 of that, so we'll get 13,600 kg per meter cube. Okay, and the contact angle between this, that means the theta given, the theta value given for this is 130 degree. Okay, so what we need to calculate? We need to calculate the capillary rise. That means the H value we need to identify. So this H value we need to calculate for two things. One is for water condition, another one is for mercury. So first one we'll see, we know that H equal to, the formula is 4 sigma, and this is cos theta divided by, I think, rho g d. So this is the formula for both conditions. Okay, so first one, for water condition, for water, H equal to, same formula will be there, but the theta value here actually that will be considered as 0 degree. As I told you previously, the angle between the surface of the glass or glass and the contact between the glass and the that surface tensile force, that will be neglected and it will be considered as 0. So cos theta will be taken as 0, so that will be 1. So now remaining what? Now 4 into sigma. Sigma value 0.0725 divided by rho. Rho is nothing but here 1000 we can consider, and g value we know that 9.81, and diameter already given 2.5 millimeter, we can convert it into meter. So 2.5 into 10 to the power minus 3 meter we can write. So these things we can write here. So 2.5 into 10 to the power minus 3. So what we'll get here? Let's solve it. So we can get 4 into 0.0725 equal to 0.29, and divided by, we can do one thing, 2.5 bracket we can give, and we can solve it also, otherwise we can solve like this also, and divided by 9.81. So we'll get 0.0118. okay, because I'll tell you, let me write 0.0118. okay, this 10 to the power 3 and this 1000 I have cancelled this one, and this one 4 into 0.0725 divided by this I did. So this will get this much meter. So this much meter we can convert into that millimeter or centimeter we can convert. So will be converted into centimeter na 100 will there. So 1.18 centimeter. This is the height rise in the for the water. Okay. Similarly, the second one is for mercury. For mercury also you can write H equal to, again same formula, but here theta angle already given 130 degree. So you can write 4 into sigma value is different. Sigma value you can see, this is the sigma value for Mercury. So 4 into 0.52 into cos theta. Cos theta equal to 130 degree and divided by, again, rho value here I have already calculated rho value, so that is nothing but 13,600 into G 9.81, again similarly 2.5 into 10 to the power minus 3. Okay, so if you solve this one, I think we'll get some value near about, let's see, 4 into 0.52, 4 into 0.52, and cos 130 degree, that will give a negative value. So divided by this one, 1000, we can take it here, then we can cancel this one. So we can do 13.6 divided and 9.81 divided 2.5, so 0.006 into this cost, this is the value, into this cost 130 value, that will come in negative. Okay, and finally I think we'll get the value of H equal to, so minus value will come here, minus of, you can see 0.004 meter. Okay, and this one we can write in centimeter, in about 0.4 minus 0.4 centimeter. So this negative value, what you can see, this indicate there is a capillary depression or a capillary fall is there in the capillary tube, in the tube. So for this water, you can see there is a rise of 1.18 centimeter, and for Mercury case there is a capillary fall of 0.4 centimeter. Okay, so I hope you understood this question. Let's see one more problem related to this. Now here, calculate the capillary effect of millimeters in a glass tube of 4 mm diameter. Again, D given, that is 4 mm. Similar kind of question, I think this is 4 mm diameter given when it is immersed in water and mercury. Okay, two things again. One is water, another one is, second one is mercury. Okay, so both we can calculate. Now temperature of the liquid is given 20 degrees centigrade, that is not required for us, but still we can write what is the data given here, and this one we can write 4 into 10 to the power minus 3 meter. And the value of surface tension for water and mercury is given in contact with the air, that is sigma value 0.07357 Newton per meter, and this is given sigma equal to 0.51 Newton per meter. The contact angle with, for water is given 0. So again here it is given 0 degree, and here theta equal to given 130, and the density of water need to be taken as 998 kg per meter cube. And one more thing I think not given, maybe that density of that also we need to consider for the mercury, that also can be taken. Now here again we know the formula as we have solved previously, H equal to 4 sigma cos theta value 0 degree, so 1, again rho GD we can equip it, and we can solve this one. Similarly here also we can do the four sigma cos theta divided by again rho GT. So we'll put the value of this 4 sigma 0.07357 and divided by 998, and this 4 into 0.07357 divided by 1000 into 9.81 into diameter 4 into 10 to the power minus 3. So this is one, and this one 4 into sigma how much, 0.51 into cos theta, again cos 130 So here also we'll get some negative value, and divided by 1000, here not 13,600 into 9.81 into diameter. How much is there? 4 into 10 to the power minus 3. Okay, so mostly similar kind of question this is. So we'll get here. Again, we can solve this one with the help of calculator. So the value is, 4 into 0.0735 divided by, we'll go for bracket, 9.81 into 4, bracket close, answer 0.00749. 0.04749, near about 0.0075. So that we can write 7.5 millimeter. So this one we can write 0.0075 meter. Okay, and this one we can write in terms of millimeter. If you want to write that one, we can write 7.5 millimeter. Similarly, h for this will get, by solving this one, we'll get some value near about h equal to some minus value. Will get it here actually. That minus value will be taken as a suppose 2 point, near about this will come actually 2.46 millimeter. Okay, so what we can see for mercury case, there is a depression is there. There is a capillary fall, and for water case we can see there is a capillary rise is there. Okay, so this is the method to calculate or solve the problem related to capillarity. So I hope you understood how to solve the problem. It's very easy. By using the formula directly, we can use this, and this kind of questions will be given for 2-mark question or objective type questions in the competitive exams. So if you know the formula, immediately we can solve it within a fraction of a second. So I hope you understood. If you are having any doubt and query related to this, you can give a comment on the comment box. Thank you all.